Hello and welcome back to another D3D12Ez video here on the Fussel channel. Now in the last video we have created ourselves a window, a Windows window. So if I now start my DirectX application, we get a bit of DirectX initialization and a completely DirectX unrelated Windows window, an HWND. This is the HWND. You can see that I can drag it around. It works like a normal window. I can maximize it even though it looks a bit ugly. I can restore it, I can minimize it, I can open it back up, I can grab it, and I can resize it. So basically everything that you would expect that a window can do can be done by the D3D12Ez window. Now what we want to do now is we want to now attach this D3D12Ez window with a so-called swap chain. A swap chain is a construct of DXGI that binds this HWND with some DirectX 12 resources. So basically what the swap chain does is it is creating us two textures, so two images that are exactly the width of the content area, or better to say exactly the width that we specify, which is going to be the content area, so the client area of the window. And DXGI makes sure that these resources are created, managed correctly, and are accessed correctly. And what we basically do is we interact with DXGI with the swap chain. We tell it when we have finished drawing into the texture buffer, and then what DXGI does, it is logging the resource and it's talking with the Windows subsystems to draw it inside of the window, to do full screen optimizations, and many more things behind the scenes, which basically should then result in a DirectX 12 buffer that can be displayed on the window. And that's exactly what we want to do. Long story short, we want to write to that window. And that's what we want to do today. So let's directly dive into the window and let's start by implementing the features that we need. So the first thing that we need is the swap chain itself. The swap chain is again a COM pointer, so we're gonna store it in a COM pointer. Maybe let's move it down here and let's call it swap chain, like that, swap chain. Now what is the swap chain? IDXGI, because it's a DirectXGI thing, so graphical infrastructure, how it is called, and we want to create it as a swap chain. You can see there are multiple. I think the most modern one, not 7, 5, no, not that many. Swap chain 3. Okay, so swap chain 3 is the latest swap chain, so let's use that one. There we have it, swap chain 3. Now what we want to do is we want to create that swap chain. Now how do we create a swap chain? Well, we're going to create it when we call init. So after all the window stuff has been done, we basically returned that window is not equal null pointer. Well, what we could do is we could quickly check if the window is null pointer, and if it is null pointer, we return false. Did I do it like that? Yeah. So then we have validated that the window is correctly, and let's now go into the swap chain creation. So how do we create a swap chain? Well, for the swap chain, we need the DXGI factory. Not quite sure if we already got that one. This should be somewhere. Did I... D3D support, debug? No, we do not have a factory. So we need a DXGI factory. The DXGI factory is responsible for making sure to have access to several DXGI features. So currently, as you can see, in the DX context, when we called init, I just normally created a device and all the cute stuff, allocator stuff that we needed by calling init here. And what I want to do now is, while DXGI is initializing, or DX context is initializing, I also want to get myself a DXGI factory. We need the DXGI factory for more than one thing, or we could need it for more than one thing, so we should also make sure to have it globally available. So an IDXGI factory. I think that one was 7. Right, yeah, that the factory was possible to create until 7. So let's add the DXGI factory in here, and this is basically just a class that contains a set of factory functions that we can use to, like, for example, create a swap chain. Now, of course, we need to assign it. How do we assign it? Well, we actually should assign it even before we create the device. So let's do it in here, false. And let's do a DXGI or create DXGI factory. We take the latest one, the create DXGI factory 2 function. Flex is going to be empty, and then we just have an IID PPV args to our DXGI factory. What did I do wrong here? Expand to cast between integer types. I know why, but Yeah, now it's gone. Yeah, that's exactly how we do it. We create a DXGI factory, and if it fails, we return false. Now clean up. Yeah, we should be able to just clean it up here. DXGI factory. Release, the proper release one, to also clean up DXGI resources. So now we should have a DXGI factory available. Now we just need a way to expose it. So let's do a inline com pointer IDXGI factory 7 reference get factory, like that. And let's return my DXGI factory here so that we have access to it. Okay, so now let's go back to the window and let's now actually use it. We have not included the context, so let's do that. Let's go to D3D context and include it so that we can use it. And now we can go to window.cpp and get ourselves the factory. So let's do auto reference factory is equal to dx context get factory. So now we have access to the factory, and now we can ask the factory to create ourselves a swap chain. Now there are multiple functions for creating a swap chain. There's a old create swap chain. You should never use these, and nowadays you should use one of the 3 modern versions for composition. This is for like modern Windows like Mica and acrylic design. They use the thing called like composition, and yeah, you should basically use the create swap chain for composition. For those cases, you have the function to create a window for a core, or to create a swap chain for a core window. A core window is a Windows Universal Platform window, so UWP. We don't have this as well. We want to create it for an HWND because we have a classical window. So we want to create that one. Now, as you can see, we have multiple parameters for that function. The first one is a pDevice. This is a so-called device pointer. However, in the case of DirectX 12, this is actually not a device. It is actually the command Q that's used. So actually what we need to do is we need to get the common queue for that one. It's a bit misleading on DirectX 11, since these functions are shared between 11 and 12. It is actually the device. However, on 12 it is the common queue. Now the next thing that we need is an HWND, so the actual window that we want to create a swap chain for, which is my window handler. Then we have a swap chain description. It's sadly not fitting because I scaled up the text here. It requires maybe let's peek inside of that so that you can see how it works, like the device, HWND, and then we have the swap chain description. We have the swap chain full screen description, a DXGI output, and a swap chain 1 pointer. So the general idea is this function takes 2 descriptors, one for the normal swap chain description and one for a full screen description, which basically tells how the swap chain shall behave in case it's full screen. Yeah, and then we have output. This is optional, as well as these full screen description. However, we're going to actually specify that one. And then we have the com pointer, which is the output. You're going to see how we deal with that in a second. So let's first of all create the actual descriptor. So create swap chain, and here we want to describe swap chain. Now, DXGI swap chain description. Was it a normal one or a description 1 or something like that? Let's see. It was a swap chain description 1. Yeah, that's exactly what I thought. SVD, swap chain description. DXGI full screen or swap chain full screen description. Where is it? Swap chain. What is the full screen description? Let's see again what this is. It's always hard to remember the stuff. Swap chain. Full screen desk, not desk full screen. Swap chain, swap full screen descriptor. Yeah, no, these names are cryptic, but that's just how I like to do it. So SVD and SFD here. Then we have the restrictor output. We don't want to restrict it, so we set it to null pointer. And then we need an IDXGI swap chain 1 pointer. So actually what we can do is we can create ourselves an IDXGI swap chain 1 pointer. I don't know why it doesn't take IID PPV args, however, just the case here. I'm just going to call this one SC1. And what I do, instead of putting it into the final one, I put it into SC1. And what I now going to do is I'm going to call query interface on that. And I'm going to specify my swap chain, the final swap chain. And this should return a Boolean. So if not, if this one fails, we're going to return false. So something like that. This is basically... This query interface with the dot and not the pointer is my one, which is basically templated and resolves to IID PPV arg and handles the H result, evaluates the H result so that you can easily do something like that. Now this is everything that we need to create the swap chain. Now let's actually describe the swap chain. Now I want to go into that and copy myself all the parameters so that we can specify the swap chain here correctly. And then what I want to do is I maybe want to paste all of these in first. Let's remove something that's common, and then let's do it like that to make it scalable. There we go. Now we have that. Maybe we can, I don't know, can I kinda? No, it's always like wrapping over to the next line. This is something that I don't like. Now let's describe this a bit. Let's say the width, we had an initial width of that value. We had an initial height of 1018. Now the format, you just need to bear with me what it is. The XGI format, R8, G8, B8, A8, UNorm. This is the default format of a swap chain. This basically means 8-bit for red, 8-bit for green, 8-bit for blue, and 8-bit for the alpha channel. It is just how the default buffers roll. Swap chain with different format is not really something that you should do. Only if you are having like an HDR monitor, then you would of course use an HDR format here. However, this is like the normal format that the display uses. So this is what you should provide here for the swap chain. This is the resulting format that your buffers are gonna have, and this is the normal default one that you will use. So basically we just specify all the color channels that are available, which is RGBA in this case, and we also specify the bit width, which means 8-bit per channel, which means 0 to 255, which is the format of a normal monitor. And UNorm is the kind of like number format. UNorm means unsigned normalized value. Normalized means between 0 and 1, and unsigned basically means it goes from 0 to 1. If it would be signed, it would probably be -1 to 1. However, we want to have it unsigned, which means 0 to 1 is the scaled value. And since these are like the default color values that you use in real-time rendering, you should always have it at that format. Now the next one is the stereo. We want to set this one to false. This stands for 3D. We don't want to use 3D. Now the next thing that we need to fill is a sample description. This actually has a count and a quality value. Oh, I didn't want it to jump there. Now what you need to do on DirectX 12 is always set this to 1 and 0. Count is 1 and quality is 0, which basically means this is for multi-sample anti-aliasing. Quality 0 means no multi-sample anti-aliasing, and count 1 means like 1 pixel per pixel. Now multi-sampling normally works like that you have multiple pixels that are basically evaluated per pixel base, and then later on with a coverage analysis and coverage values, a final value for a pixel is resolved. We don't use that one, and it's not supported on a swap chain for DirectX 12. On DirectX 12 you need to do it manually, so you should set this always to 1 and 0. This is only mattering for DirectX 11. Now let's specify the buffer usage. The buffer usage means how you're gonna use it. This is the XGI usage. The XGI usage, and what you want to say is usage back buffer, because you want to draw to it, and if you're drawing to a buffer, it is a back buffer. And what you also want to use it is for a render target output. Render target output means output to a window. So the swap chain is now used as a so-called back buffer, which means that we can write to it using the GPU, rendering to it, bind it as the render target. And output means that we want to output this to an HWD. So it's kind of like optimized for writing on the GPU and also writing to a display. Now the next thing that we want to specify is the number of buffers. This is nowadays going to be 2 or 3. These are the most plausible values that are possible. Earlier 1 was also a supported value, but I think DirectX 12 doesn't even support it. Now, so if you have 1 buffer, it basically works like that. You write to the buffer is displayed on the screen. So basically the buffer that is used to serve your display is also used for rendering, which means that if you are clearing the buffer, it's directly visible on the screen. You are basically having 1 buffer that's accessed by two sides. One side is writing to it, this is like your application, and one side is reading from the buffer, which is your monitor or Windows that is kind of like serving your monitor. And the problem with that is if you are writing that, it's directly visible on the monitor. This can be solved by setting this to 2. If you set this to 2, you basically have 2 buffers with their own dedicated usage. 1 buffer is displayed and 1 buffer is written to. So what you do is you write to the buffer, which is kind of like so-called a back buffer. This is where that name is coming from. It's a buffer that's not currently displayed. You write to the back buffer, and as soon as you are done with the back buffer, you're gonna swap the buffers out. So you take the current back buffer, put it on the screen, you take the current screen buffer and take it as a back buffer. This is why it's called a swap chain, because it's responsible for swapping these buffers out. And if you would just have 1 buffer, the name swap chain would kind of like be irrelevant. However, I don't know if it's still possible on DirectX 12, but earlier it was possible on older DirectX versions. So the general idea that we have here is basically we have 2 buffers. 1 is displayed, 1 is written to, and then they are exchanged. Now there's also a value of 3 that's possible here. Now why would you want to use 3? Well, because of something called vsync. Vsync is the process of waiting until the monitor is done drawing 1 buffer. So basically what the monitor is doing, it is taking the current kind of like front buffer, the current buffer being displayed, and it is reading it. It's starting at the start of the buffer, reading it sequentially until it gets to the end, and then it starts back at the top and reading it again. So it's basically reading and reading and reading and scanlining that to the monitor. Now, the problem is if you are swapping the buffers while it is reading it somewhere in between, it, for example, has read the first half of the screen from the current front buffer or the current display buffer, the current presenting buffer, and then you do the swap, and then you're kind of like reading from the next buffer, which can result in discontinuities on the image, which is known as something called tearing. Because most of the time your application is not doing it synchronously, you have a bit of jitter in it, and the jitter means that the point where you are kind of like swapping the buffer is kind of like traveling across the screen, because it's always a different time. The monitor is not running synchronously, and then you see something that is called tearing because the camera position has changed or the display position has changed to the previous frame, and then you kind of like have a discontinuity in the image, which is then called tearing, and it's possible, and since it's not synchronized, it's kind of like traveling across the screen up and down or something like that. And for that, you need something called vsync. And vsync basically means that you wait until the monitor has finished reading 1 buffer, and then you exchange it in the pause that the monitor is doing before it's reading the next buffer. Or basically, especially if you get to something like NVIDIA, like G-Sync or FreeSync on the AMD side, you basically always tell the monitor, now wait. Now there's the next buffer. Continue drawing it. Continue drawing it. So kind of like that's kind of like the idea here. Like every time a frame has finished drawn on the screen, you gotta give it the next one. And vsync has a problem in performance because it basically needs to wait until the current frame has finished drawing on the screen. So you are always limited by the monitor. And that's a thing that you might not want to do. And this is why we have 3 buffers. So you have 1 buffer that is currently displayed on the screen, 1 buffer that you draw to, and 1 idle buffer. Now, as soon as you are done drawing to the back buffer, you basically put it into a queue and say, hey, monitor, or hey graphic card, or hey driver, as soon as the current image has been drawn to the display, take that buffer that I have just finished drawn. So you put it in the queue and you give it to the driver and say, deal with it. This is the next buffer on the next V-blank, it's called. As soon as the monitor finishes drawing on the next V-blank, take the buffer and use that for drawing. And what you then can do is, while that 1 buffer is waiting for being displayed on the monitor, you can take the 1 idle buffer and already start drawing to that one while the GPU is staging the just finished buffer for displaying on the next V-blank. And the nice thing is, of course, as soon as the V-blank is coming, the old buffer that's been displayed is now being turned into the idle buffer, and you always have a buffer available. So nowadays what you use is 2 or 3 buffers. Now we're not going to have to overcomplicate it, so we're going to set it to 2. Now the next thing that we want to set is the scaling value. Now the scaling value is basically defining how the SwapChain shall behave if the width of the SwapChain buffers and the actual client width of the window or of the screen is not matching. This is something that should never happen, but it's something that you need to describe to basically tell it what to do in case it happens. And it will happen because you're not doing, the resizing is not being done synchronously. When the window is resized on DirectX 12, you basically put kind of like this event into your application. You kind of like stage, hey, my buffers need to be resized, and you do it on the next occursion. And during that time, we need to have a method that needs to be done. And in this case, DXGI scaling stretch should be used. So basically what we're going to do is we're going to stretch the image to fit on the screen. Now the next thing that we want to specify is a swap effect. The swap effect is describing how swapping the buffers is handled, so how exchanging the back buffer and the front buffer is done. So DXGI swap effect, and we want to say flip discard or flip sequential. This is something that you need to do a bit of research in it. In general, DirectX 12 is only allowing you flip discard and flip sequential. I think flip discard is the thing that we want to have. And we're just going to use the flip discard one. Just bear with me, it is the correct one. Now the next thing that you need to specify is the so-called alpha mode. The alpha mode is the mode that's used for alpha blending. Now in general, what do you want to do? How is it called? DXGI alpha mode. I don't know why Visual Assist is a bit bitchy. Alpha mode, ignore. This is something that you always want to set to ignore. Now what you also have is you have a few flags. You always want to make sure that you specify these flags. The first flag that you want to say, SwapChain flag, is the flag allow mode switching. Allow mode switching basically tells that your SwapChain is kind of like, modifiable. And then what we also want to do is we also want to say allow tiering. Allow tiering is basically enabling to not vsync the image, and most applications that you're going to write are going to have these two values supported. So that's what you want to do. You want to always specify these two flags. Now the next thing that we need to describe is the normal flags here, this flags for the full screen. Now, what we want to do is we want to first of all set windowed to true. I don't know which order they are. Let's peek in here. They are on refresh rate, scanline ordering, and scaling, and windowed. However, all these three are irrelevant if we are setting windowed to true, because if we are on windowed, we are not on full screen mode, on a classical full screen mode, and this means that these values are not going to be used. So we set this to true, and everything else should be fine. Now let's quickly return true here so that we see that everything is good, and let's go to the shutdown function and make sure that our SwapChain is also released before we shut down everything. Now this code should already allow us to create a very basic SwapChain on our window. Let's run it and see what we got. Okay, so you can see that we got a window. However, as you can see, it did not really change anything. And this is actually correct because the SwapChain has not been driven yet. Currently, the SwapChain is created. It has created all its resources, and the SwapChain is basically ready to draw the first image, but it's not doing it because we have not told it. What we now need to do is we need to call a function called present on the SwapChain. Present means exchanging the current back buffer with the displayed buffer. So in our window, we have the update function, and inside of that update function, we want to actually now also like maybe, or do we want to have an update function? Maybe let's do a dedicated function for presenting. Let's do a void present without parameters quickly. We can later on add them if we need them. And let's implement the present function here. So what we want to do in present is we want to go to our SwapChain, and now directly on the SwapChain. And what we want to call is the function present. Now, the SwapChain has two parameters for prevent. The first is the sync interval. If you put 0 in here, it means that you want to tier and directly present it. If you put 1 in here, it means on the next interval, so on the next blanking. If you would put 2 in here, it would basically wait 2 frames, so you would basically halve your frame rate. This would be, for example, useful if you are in a menu or in a GUI that is not updated often. You could like use something like sync interval 2 to basically say just every second frame, but it's just an exotic value, so normally you put it to like 1. This is like the normal thing you do. Then you have flex. They should be in DXGI, SwapChain. Yeah, let's look them up quickly. The present flags on the SwapChain. Let's see quickly how the flags are defined. DXGI present are the constants. You can put a few things in here like allowed hearing. If you put in allowed hearing, that is required for a call with a sync interval of 0, but we do not have something like that. So what we want to do is we want to have a normal call to present with 1 and 0, and this should now present the window. Now presenting of the window should be done after the comment list has been executed. So where we have our show my stuff, there we should present it. So actually I want to get my DX window now, and I want to call present on the window. So let's say, yeah, we update the window here, which is basically polling the events of the window. Then we get ourselves a comment list. Down here we want to do our rendering. Then we execute our comment list, and then we are presenting the result that has been just executed, and we are kind of like ready to draw again. If I run that, we should ideally, if I didn't make any mistake, already get a window that's served by SwapChain. You can see that because it's black, and black means that there's something going on. And if I resize it, you can see that the window actually stays black because we are doing scaling, which basically means that our 1080p SwapChain is scaled to the size of the window, and it's completely black, which means SwapChain is working. This is now actually, congratulations, some DirectX stuff. Could we see that this is DirectX stuff? Maybe. Oh, we do have exceptions in here now if we are stopping our application. I'm getting to this in a second. I could try, let's see, MSI Afterburner. MSI Afterburner is doing, so we could try opening up MSI Afterburner because MSI Afterburner is detecting stuff. However, MSI Afterburner is gonna really, screw up your debug layer. So you should not use it during development. I just want to show you that we have actually a DirectX 12 window. You can see that it's doing something, 60 FPS, because I have it on my 60 FPS monitor. You can see that it's not looking right. It's not looking right because basically we are never clearing our buffer. This is why all of these numbers are like, overlapping each other. We are never clearing the content of our buffers that we render to, and so they stay the same. We need to clear them always, but we haven't done this yet, and this is why it's kind of like looking that ugly. But you can see D3D12, 60 FPS. I have the 60 FPS monitor. If I would drag it onto my different monitor, it's going to increase to 144 FPS, or actually, yeah, even more as it seems. Okay, I cannot really see it because it's like overlapping the numbers. But you can see like 160 because I have multiple frame rates in the monitor, so this actually works. Now if I close it, we're gonna again, oh no, we didn't get an issue. The issue is actually a random issue that occurs on random times. However, there's a reason to that, why we sometimes get an issue if we are closing our application. Now basically this is now how the SwapChain is being driven. Now, what we now need to implement to get rid of the issue, let's see if I can quickly reproduce it again. No, can't reproduce it. Let's try it out again. No, come on. There must be a way to reproduce it. Of course, it just worked one time. Okay, interesting. Let's close Afterburner. Can we... There we go. Now we got it again. Now, what is the problem of that issue? Well, we actually got a message from the debug layer as well. The debug layer is telling us ID3D12 resource. An ID3D12 resource object is referenced by GPU operations in flight on command queue, unnamed command queue. It is not safe to find or release objects that may have GPU operations pending. This can result in application instability. Now, basically what it's telling us is that a resource is used and we tried to release it. Well, why did we try to release it? Well, now I, of course, because I'm an idiot, I already stopped it, but if we would have looked at the call stack, it actually occurred when we tried to release the SwapChain. So that call basically had the issue. Why did that call have the issue? Well, because the SwapChain is maintaining two buffers, two ID3D12 resources, and as soon as you are releasing the SwapChain, these resources are released as well. However, these resources are also referenced in our command queue, the command queue that we have passed in while the creation of the SwapChain, that command queue still has reference to that buffer in here because the SwapChain is basically talking to the GPU while with the comment queue when we call present. So if we call present, it's basically putting some work on the comment queue that is presenting the frame. And if we are releasing the swap chain while there's still some work associated with these resources ongoing on that comment queue, we get this issue. This might not always happen because the work might have already finished, but this can happen. And this would release or would basically result in a resource corruption. And we want to actually fix that. Now, how can we fix that? Well, it's actually quite simple. We just need to make sure that we are flushing our comment queue before we are getting to our shutdown procedure. So basically what we want to have here is flushing. We want to flush the comment queue and make sure that all work of the comment queue is finished by basically signaling it. And we actually need to signal it multiple times because there are multiple frames that can be in flight. If we have 2 frames, there could be 2 frames that are referenced on the GPU. If we have 3 frames, we can have 3 operations that are queued on the GPU. So we need to actually make sure that we are flushing it as many times as we have buffers. Don't really ask me why this is working. Normally you would think if the call here is synchronously, just one call would succeed. However, you need to flush it as many times as buffers you have. So just a simple rule, flush it multiple times in here. Now, to make this a bit more robust, what I'm going to do is on the DX window, I'm going to do a const or a static const expression get frame count, or let's say size t, get frame count. That is basically going to tell how many frames there are in flight. In this case, I'm going to say 2. And this get frame count is now going to be injected into my application. So for buffer count, I'm going to use get frame count. And now I can also use it later on in my main to flush the comment queue. However, flushing the comment queue needs to be implemented. You can see that we have this void signal and wait. And what I want to do is I want to write another void flush. Or actually, let's do an inline because we can inline that. Let's make it maybe here. An inline void flush to flush the GPU, and let's put an account in here, and inside of that I'm basically saying for size ti equals 0, I smaller count, I plus, and then I'm gonna execute signal and wait in here. And this basically is gonna signal and wait as many times as we put in count in here, which is exactly what we need to do to flush the comment queue. Remember, signal and wait is basically putting a signal event on the comment queue and then tells the fence to wait until that signal has occurred. And this basically means if we're putting 3 of these or doing this 3 times in a row, that we have 3 times set a value, waited for its completion. And that's probably what we need somehow on the comment queue to make sure that everything is good. Probably there is something going on asynchronously going on with the XGI that is also waiting until the queue is finished and then putting some work on it, waiting again and until it's finished, until it's kind of like done with its own internal like queue buffer on the CPU side that has at a maximum number of events, like the maximum number of frames that you have. So to flush it, it's actually quite simple. We just now need to call on the context my flush method, and I am taking my window in here and I'm going to just get the frame count to flush it before I'm going to go into my shutdown states. And this should now prevent the issue. Now, I could run this now 1000 times, but I think you just need to bear with me that it works. Because it was already hard enough to reproduce the issue when we wanted it to reproduce. But now it's not going to happen, right? We do get a bit of some warnings down here that we might want to address. We have a live device and a live fence that I forgot at some point to do a bit of cleanup. Yeah, fence event, comment queue release. Yeah, we forgot to release a fence here. But that's like an issue from an older video. I don't know why I haven't addressed that back then, but let's release the fence here. This should also fix that issue. Yeah. Okay, so a rather long video for not really something that we have achieved. We did not even make sure that SwapChain is in the right size, but that's something that we're going to do in the next video. for now, sorry, we couldn't do more. Thank you for watching. See you in the next video. Make sure to like and subscribe. And yeah, have a nice day. Bye.